Good morning, dear students of grade 9. Today we are going to discuss or we are going to practice the numericals on SUVAT, or you can say equations of motion. We have just tried to derive equations of motion in our previous class. Yes, so by using this equation of motion we are going to solve some numericals on SUVAT, and before doing that we need to keep certain things in our mind. Okay, and first of all you need to know that indication of each term in SUVAT. S means distance and its SI unit is meter. U means initial velocity, its SI unit is meter per second. V means final velocity and SI unit meter per second. A means acceleration, unit meter per second square, and T means time, unit second. This much we have already discussed in our previous class. And then we also derived these equations. There are 4 equations in SUVAT. First one, V equals to U plus AT. Second one, S equals to U plus V by 2 into T. Third one, S equals to UT plus half AT square. And fourth one, V square equals to U square plus 2AS. Okay, you should know all these 4 equations by now. And there are few special conditions, okay, while performing numerical and SUVAT. Okay, and the first condition of them is if an object starts to move, then initial velocity is always 0 meter per second. It starts to move means initially it is not moving. That's why U equals to 0 meter per second. If an object comes to rest, then V equals to 0 meter per second, means it comes to rest, means finally its velocity becomes 0. Okay, see, if an object starts to move, the question says if an object starts to move, then U equals to 0 meter per second, and if an object comes to rest, then V equals to 0 meter per second. Okay, and third condition, if an object is thrown upward, then final velocity is 0 meter per second and its acceleration would be negative of 9.8 meter per second square. Because you can see, if an object is thrown upward, then you throw the object upward with certain velocity, which would be its initial velocity, and after reaching certain height it stops. Okay, when you throw an object, it does not continuously go up and up, but it stops at some point or at some height. That means finally its velocity becomes 0. That's why V equals to 0 meter per second. Okay, and when an object is falling or thrown upward, then the acceleration of the object would be equivalent to acceleration due to gravity, and in case of Earth it is 9.8. and since when object is thrown upward, its velocity keep on decreasing, acceleration would be negative. That means it takes on retardation. And next one, if an object is falling, then its initial velocity would be 0. Before you throw an object downward, it is at a state of rest, so its initial velocity is 0 and its acceleration will be equivalent to 9.8 meter per second square. And keep that much thing in your mind. We are going to solve a question now. Okay, read the question. The question says a car has a uniform acceleration of 8 meter per second square. Find the distance covered in 4 seconds if it starts to move from rest. Okay, what the question says, a car, it starts to move at the beginning point. Its speed is 0 meter per second. Yes, because it says it starts to move from rest. Okay, see the condition number 1 again. If the object starts to move, then U equals to 0. So here it says the car starts to move from rest, means its initial velocity would be 0, and after moving for certain distance, it keeps on moving until 4 seconds. Yes, it says it distance, find the distance covered in 4 seconds time. We need to consider 4 seconds of its motion. At the end of this motion, what should be its velocity, that we need to find. Okay, and what distance does it cover, S equals to what, that also we need to find. Okay, now here what informations are given. Okay, I always use a method, okay, a systematic method, in which whenever I try to attempt questions, numericals relating to equations of motion SUVAT, then what informations are given by question, I do not check that first. What I do, I take out the I write down all the informations, like we have distance traveled or S. Okay, we don't know what is its value. Then SUVAT, I'm going to write down all of them. Initial velocity U equals to, and final velocity V, acceleration A, and time T. Okay, see, SUVAT. I'm going to take out all of them. Okay, I don't know what informations are given, okay, by the question. I haven't gone through that yet, but whatever information are given or not does not matter. I simply am going to write all of them. Okay, SUVAT in order. SUVAT, SUVAT. Now let's see. A car has a uniform acceleration of 8 meter per second square. Definitely 8 meter per second square is the value of acceleration, and I'm going to write it down here. 8 meter per second square. Then find the distance covered. See what it says? Find the distance covered. Okay, distance covered means S, and the question asks us to find it, so we do not know it. Let's put a question mark here. Covered in 4 seconds. What is 4 seconds? You know, seconds is a SI unit of time, so 4 seconds must be value of time. 4 seconds. And then after, if it starts to move from rest, and as I already told you, it starts to move from rest always means initial velocity is 0 meter per second. Now according to question, final velocity is not given here. Okay, final velocity is not given, and the question does not ask us to find it as well. So this information simply is not necessary. So at last I can simply cut it down, or I can put cross mark here. That means I do not need this information, or if you feel uneasy, then simply cross it out. This is what I do whenever I perform a SUVAT numerical, and it makes it easier to take given informations. Okay, this is step 1, and in step 2, what I do, I take out all the equations in rough. All 4 equations I write in rough at one of the side of paper. Okay, p square equals c square plus 2as. I do this. Okay, then after I simply check on which equation have these 4 terms, S, U, A, and T. Okay, now here in this equation, let's check. It has V, U, A, T. It has 4 factors. Yes, among them we do not have V. Okay, we do not have V, and then after U is given, A is given, T is given. Okay, and since this equation has only one unknown variable, only one variable is unknown, we can use this equation. Definitely we can solve this equation. Remember, if 2 variables are unknown, then we cannot solve that equation. But since in this equation only one variable is unknown, we can solve this equation. But once again, V is not needed. Okay, we have crossed it out. V is not needed. So whichever equation involves V, we can simply cross it out. See, in this equation also there is V. Do we need this equation? No, we do not need this equation. Cross it out as well. Now it has become quite easier. This equation also has V. We cannot use this equation as well. So that narrows down to only one equation. See, we have only one equation remaining on our hand, that is S equals ut plus half at square. Are you getting what I'm saying? Since we do not require V, okay, we do not need to find out V, and the information about V is not given by question, we simply do not need V. So whichever equation have V, simply cut them out. The first equation has V, second equation has V, and fourth equation has V, cut them out. So that narrows down us to single equation, that is S equals ut plus half at square. Now I'm going to use this equation. Okay, as we know, Okay, we are going to this s equals to ut plus half at square. As you know, s we do not know. U, see here, u means 0. T 4 plus 1 by 2 into a, value of a is 8. T, value of t is 4, and there is square. Okay, I simply replace the value here. Value of s is not given. Value of u is 0. Value of t is 4. 1 by 2 as it is. Value of a is 8 and value of t is 4. So t square means 4 square. Now let's solve this. 0 into 4, 0. 1 by 2 into 8 into 4 times 4 means 16. We can cancel here. 2 4s are 8. And therefore, s equals to, solve it, you get 16 4s are 64. 64 meter. This is the answer. Therefore, the car covers 64 meter distance. Okay, this one. See, it's not that hard. Yes. First of all, read the question. Okay, read the question. Then step 1, take out all the given information. Just list down all the factors involved in SUVAT. List down all the factors involved in SUVAT. That means SUVAT. Then read the question again. Whatever information is given by question, just take it down here. Then after, list out all the equations of motion that you have. Then which factor is not given by question and which equation contains those factor, simply cross them out. You'll narrow it down to single equation. Then use that equation to solve your question. Now let's go to our second question. Let me copy that question. Okay, let's see the question. It says a body is thrown vertically upward with velocity 72 km per hour. Find the maximum height reached and time taken to reach the height. Since the object is thrown upward, that means this velocity must be initial velocity, because as per our special condition we discussed previously, see, when an object is thrown upward, its final velocity would be 0. That means the velocity given by question must be initial velocity. Now let's follow the step once again. Here, okay, what are the given informations? Distance s, then initial velocity u. I'm following the steps. Okay, initial velocity u, final velocity v. I usually use this as a protocol. Acceleration a and time t. See, what I have done is I have listed out all the factors involved in SUVAT, involved in the equation of motion. It is quite easy to remember. SUVAT, S-U-V-A-T, SUVAT. Okay, all the factors that are involved in SUVAT. Okay, now let's read the question again and take out whatever informations are given or asked. A body is thrown vertically upward. Whenever it says body is thrown vertically upward, then we already know two factors. Yes, as see here, what I going to say. If an object is thrown upward, final velocity 0, a equals to minus 9.8. Okay, this statement, the body is thrown vertically upward, it means we know these two informations. Its final velocity would be 0 meter per second and acceleration minus 9.8 always. Okay, this single statement gives us two information. With velocity 72 km per hour, that means its initial velocity is 72 km per hour. Wait. We have a problem here. See, initial velocity, it has different unit, must be in SI unit, and its SI unit is meter per second, but it's given in kilometer per hour. So the problem here is we need to convert it, and it's quite easy. 72 km per hour can be written as, okay, let me do it here. 72 km per hour, it can be written as 72 kilometers by 1 hour. Can we or not? Yes, definitely. Now how to change kilometer into meter? Multiply it by 1000. Yes, because in 1 kilometer there are 1000 meter. So 72 kilometer equals to 72 into 1000 meter. Okay, and 1 hour, change it into second. In 1 hour there is 60 minutes, and in every minute there is 60 seconds. So in 1 hour there would be 60 into 60 seconds. Now in spite of simply multiply them and then dividing them, what I do cancel out terms. Okay, it makes it easier to calculate. 0 0 cancelled. 6 1s are 6, 6 1s are 6, carry 1 12, 6 2s are 12. Okay, 12 6 are 72. Now this again 6 1 6, 6 2s are 12. So what are remaining here? 2, and here 10. That means it gives us 20 meter per second. Okay, so 72 kilometer per hour means 20 meter per second. You can show such calculations in rough here, and you don't need to cut it out. Okay, actually it is very good habit to show rough on the side of your paper. It proves that you are not cheating from anyone. Okay, so it can be substituted by 20 meter per second. And let's see, find the maximum height reached. And as I told you, when an object is thrown upward or object is falling, then maximum height correlates to distance traveled. We don't know it. The question says find it, put a question mark here. Okay, and time taken. Okay, time here also put a question mark. Okay. So in this question, all 5 factors are required. Okay, all 5 factors are used here. So simply once again write down all the equations here. V equals to u plus at, s equals to u plus v by 2 into t, s equals to ut plus half at square, and v square equals to u square plus 2as. Okay, here now let's take from equation number 1. Once again, the clue is if an equation contains 2 or more unknown variable, we cannot solve that equation. Remember, if an equation contains 2 or more unknown variable, we cannot solve that equation. Let's start from equation number 1. It has v equals to u plus at. See, v, do we know v? Yes, we have the value of v. U, do we know u? Yes. A, yes. T, we don't know. Okay, see, in equation number 1, only one variable is unknown, so we definitely can use this. Okay, now go to second one. S, we do not know s. Cross it. U, yes. V, yes. T, no. We do not have value of t. So this equation as of now cannot be used. But after using first equation, you would already have found the value of t. Yes, in that case you can use second equation as well. Okay, and there is a second way to do. Now let's take third one. We do not know s, we definitely know t, but we do not know, so definitely know u, but we do not know t. In this equation also there are 2 variables unknown, so we should not use this equation as well. Now in this question, v is known, u is known, a is known, s is unknown. See, only one variable unknown, so we can use this equation. Okay, so the bottom line is we can use, or we can solve equation number 1 and equation number 4. Now I will not go to any other detail. I do not have to. Okay, I will not go to detailing about equation number 2 or 3. I'll just move them out of my mind for now. I'll just move them out of my mind. What I only think about is equation number 1 and 4. Now whichever equation you use first, it does not matter, simply use it. Now as we know, let's use equation number 1 first. V equals to u plus at, or v, value of v is 0, value of u is 20, plus acceleration minus 9.8, don't forget to put minus, t we do not know, or 0 equals to 20, plus into minus, minus, it gives us 9.8 into t. Now what can we do? We need to find out the value of t, means we need to isolate the value of t. For that, first of all, you need to break this sign, okay, by moving this whole term to another side. By doing that, you get the negative sign becomes positive, so you get 9.8 t equals to 20. Okay, now the minus sign has been broken. Now only remaining sign to break is multiply. So if you break that multiple sign, you have only t remaining here. 9.8 would be shifted to another side, and by breaking multiple side, you get it to denominator. Okay, therefore t equals to let me calculate it. Okay, it gives us 2.04 second. See, you have got one of the answer. Okay, now I need to find distance. For that purpose, you have an option to use equation number 2. Okay, because value of t has already been calculated, means s is unknown, u is known, v is known, t is also known. Okay, but let's you can use that also, that is an option. But for now, let's stick to our protocol. As in step number 2, what we did, we narrowed out our list into 2 equations, equation number 1 and 4. So let's use equation number 4 here. Again, v square equals to u square plus 2as, or v, value of v is 0 square, value of u is 20 square, plus 2 into value of a minus 9.8 into s, or 0 equals 20 square, 400 plus minus 9.8 into 2, it gives 8 times 2 16, carry over 1 18 19 19.6 s. Once again, let's use the same strategy here. We need to isolate s, so we should first break down this minus sign. To do so, we can shift this whole term into another side, gives us 19.6 s equals to 400. Or now once again, to isolate s, we should break down the multiply sign over here. Yes, here is multiply sign. By breaking that multiply sign, it becomes divide. Okay, now once again, let me calculate the value. Okay, it gives us value 20.4 meters. See, this is another answer. So we got both the answer. Write the conclusion. Therefore, the body reaches the height of 20.4 meter within 2.04 second time. Okay, once again, see, do you need to take question? Okay, this is the question. You can take screenshot, or you can pause the screen and copy it. Okay, and this is the solution, but use it as a reference. This is for learning purpose only. I'm going to give you another question for practice. Okay, I've copied question number 3 for you. Read the question. A stone is thrown vertically downward, that is, from certain height the stone is thrown downward. Okay, with the velocity of 5 meter per second, with 5 meter per second velocity. Okay, so its velocity keeps on increasing, and it reaches the ground in 2 seconds. It takes 2 second time before reaching ground. Yes, and find the height from which the stone is thrown. What is the height of stone? As we need to find, and also the velocity by stone strikes the ground. That means what shall be its final velocity, that also we need to find. And acceleration, as you know, when we throw an object, then it takes the value of acceleration due to gravity, 9.8 meter per second square. Yes, the exception is it gives us initial velocity of throwing. Okay, the object is not simply dropped down. If an object is simply dropped, then obviously initial velocity would be 0. But he is not dropping it down. Okay, the person is not dropping the stone passively. He uses some force to throw it. Okay, so he provides an initial velocity of 5 meter per second to throw it. Okay, that's why we do not write u equals to 0 in this case. Otherwise, as our condition, we said if an object is falling, then u equals to 0. But in this case, definitely the object is falling, but it's not simply falling, it is thrown downward. The object is thrown downward. Okay, so let's follow the steps given. First step is same, list out all the terms like height from which stone is dropped. It means S. Yes. Then U means initial velocity at which it is dropped. And then you need V means final velocity by which it strikes. Okay. After striking, it comes to 0, but that's not our point. But at what velocity it strikes the ground, that is what we need. That is taken as final velocity. Don't be confused. Some students get confused that since after hitting the ground, the stone comes to rest, its final velocity must be 0. No, that's not right. Okay, because once it hits the ground, it bounces off. Okay, or it causes an impact which changes the situation that it must be under uniform acceleration. I already told you equation of motion is applicable only when object is under uniform acceleration and in straight line. That's why when the object is falling down, only until it just hits the ground, it follows uniform acceleration. Right after hitting the ground, it does not become under uniform acceleration. Okay, that's why. Okay, and then SUVA and T. A means acceleration and T means time. Okay, time taken. Okay, let's check out the information here now. A stone is thrown vertically downward with a velocity of 5 meters per second, means its initial velocity is 5 meters per second. It reaches the ground in 2 seconds. 2 seconds. Second is SI unit of time. Let's write it here, 2 seconds. Find the height from which the stone is thrown. Height from the stone is thrown S. This is what? And also the velocity by which the stone strikes on the ground, means this is also what. And since the stone is dropping, it's falling, and the acceleration would be 9.8 meter per second square. See, in this numerical also we need to take on all 5 factors. And let's list out all the equations we have. V equals to U plus AT, S equals to U plus V by 2 into T, S equals to UT plus half AT square, and V square equals to U square plus 2AS. In this case, let's check out the equation one by one. If an equation does not have if an equation have two unknown variables, then we cannot use that equation. Let's see here. V. Do we have V? Yes. U? Yes. A? Yes. T? Yes. Okay, V is unknown. All the factors we have. That means we can use equation number 1. Okay. Now, since you have already used equation number 1 to calculate V, now you can see that you can use any of these equation. Yes, because only one factor S is unknown. Okay, and in all of these equations, only one variable is unknown, that is S. But if you do not want to count V as known variable as of now, then you can see which equation does not have V. This one. This equation does not have V. You can use this equation. See, S is known, U is known, S is unknown, U is known, T is known, A is known, and T is known. See, only one variable is unknown, that is S. All other variables are known. Okay, so you can use equation number 2. Or as I already told you, from equation number 1, you have already calculated V. Means you can use any equation. Okay, now let's go through that. As we know, we have narrowed down the equation into list of equation into two. Okay, let's use the first one. V equals to U plus AT, or value of V is, we don't know, value of U 5 plus A 9.8 into T 2, or let's multiply it, 5 plus 9.8 into 2 19.6, or V equals to 19.6 plus 5 gives 24.6. Therefore, its final velocity would be 24.6 meter per second. Okay. Again, let's use the second equation as well. S equals to ut plus half at square. Yes, ut plus half at square, or S we do not know, u is 5, t is 2, plus 1 by 2 into a is 9.8 and t means 2. 2 into 2, or S equals 2 5s are 10, 2 and 2 cancel, plus 9.8 into 2, 19.6. Therefore, S equals to, add this up, 29.6 meter. See, you got both answer. Therefore, give the conclusion. Therefore, the stone was thrown from the height of 29.6 meter and it strikes the ground with the velocity of 24.6 meter per second. Okay, and this is the solution to the third question. See, once again, you can now that you understand the question, if you don't understand, rewind the video. If you do, then pause the video and copy down the question, and then try to solve this question, solve this numerical as I did, step by step. Follow the steps. Okay, first step, list out all the factors SUVAT. Just simply list out SUVAT, and then find out these informations from question. Whatever information you find first in the question, just pick it out, okay, and put it down, list it down. Then in the rough, list out all 4 equations, and then try to navigate through equation 1, 2, 2, 3 and 4. Okay, in each equation, what you have to check, which informations, which factors are given. Okay, in each equation, just check which factors are given, and in which, if an equation has only one unknown variable, you can solve that equation. But if an equation has 2 unknown variables, see equation number 2 has 2 unknown variables, you cannot solve that equation. If equation number 3, it has also only one variable, all other variables are known, you can use this. And equation number 4, V is unknown, S is unknown, U and A are known. Yes, it also has 2 unknown variables, you cannot use this also. Okay, so we have narrowed down the list of equation into 2 equations, equation number 1 and equation number 3, and then use these equations. By using equation number 1, you can find out the value of V, and by using equation number 3, you can find out value of S. Okay, and so this was for today's class. In your group, I'll send you the questions, more questions regarding this numerical on equation of motion to practice. Okay, take it down, submit the questions by tomorrow if possible. So try to submit it just today. Okay, thank you very much.